let's enter the quantitative aspect of electrostatics. And the first thing which comes in mind is, of course, the Coulomb's law. What a name. Charles Augustin de Coulomb, the person who actually quantified the electrostatic interaction between charges. Perfect. Before I start, don't forget that this law which you're about to study is actually valid only for static point charges. Point charges is something we borrow from the classical mechanics. Okay? When you apply this law, those are considered as point charges, and also they have to be static in nature. That's why I said the law is applicable on static point charges. What does the law entail? The law says that force of electrostatic interaction between two static point charges is directly proportional to the product of the charges and inversely proportional to the square of separation between them. If Q1 and Q2 are the charges involved in the interaction, F proportional to Q1, Q2, and if they are R apart, F proportional to 1 over R square. When I club these two, I have a proportional relationship, and that relationship looks like F proportional to Q1, Q2 upon R square. I wish to convert this proportionality into an equation. Obviously, I have to add a constant. Coulomb's law upon completeness actually looks like this. Q1, Q2 separated by a distance R, F proportional to Q1, Q2 by R square, and if I actually make it into an equation, it looks like F equals K. Sometimes they use capital K, sometimes they use small k with a subscript E, depends on our choice. F equals K Q1 Q2 upon R square. K is the constant we were talking about. Let's focus our attention on that K. But before we do that, can you right now appreciate the fact that this form is actually not new to you? You have seen this form before, where in the gravitational force expression. Isn't it a almost replica, one-to-one similarity from G m1 m2 r square to K q1 q2 by r square? In fact, r square is the same thing. In G m1 m2 by r square, r was a separation. In K q1 q2 by r square, r is still the separation. m1 m2, however, were the point masses. Q1 q2 are the point charges. Capital G was the universal constant of gravitation, and there is the change, my friend. K is not the universal constant. It is a constant. More on that later. Keep watching.